Greater than, less than, and equal to. We've already talked about the symbols greater than, less than, and equal to, but we need to introduce two other symbols. One symbol is this symbol. We recognize the greater than, and if we cover that up, we would see the equal to as well. We call this greater than or equal to. Greater than or equal to. Another symbol, we combine the less than sign with the equal sign, and we call that less than or equal to. And this will help us understand some sign numbers on the number line. If we look at the first example, we see x is greater than or equal to -2. That means we want to find all the values that are either equal to -2 or larger than -2. So if we look at the number line, we find -2, and you'll notice there's a solid dot on -2. This means that we want to include this answer in our set. So we've got -2 and all of the numbers greater than -2. You'll remember on the number line, everything to the right of a number is larger. -1, 0, 1, 2 are all larger than -2. So we want to include this because it's got the equal sign in it, and we've got x is greater than or equal to -2. In our second example, we have only the example x is greater than -4. There's no equal sign in that. So we're going to locate -4 on our number line, and we know we want all the numbers that are greater than -4, so we want all the numbers that are to the right of -4. We'll include -3, -2, -1, 0, 1, 2, 3, and so on. But we also want numbers that are very close, maybe -3.5 or -3 3/4. We just want to get very close to this -4 but not include it. If there's no equal sign on our symbol, we put an open circle to indicate we want to get very close to -4, but we don't want to include it in our solution set. Finally, we have the example x is less than or equal to 3. Less than or equal to. Now the less than means we're going to go to the left of 3, and the equal to means we want to include it in our set. We'll find 3 on the number line and we'll make it a solid dot. We want to include it in our solution set. We have less than or equal to, so it's a solid dot. We'll have everything less than 3, which is everything to the left of 3. Let's practice graphing an inequality like this. Perhaps we'll graph the inequality x is greater than or equal to -1. If I had to write out all the solutions to this, it would not be possible because there are infinitely many numbers bigger than -1, so I'm going to show my solution on a graph. I'll start by drawing a number line, and I'll indicate some values on the number line. Just a few are enough. You don't need to write a great many numbers. And I'll start by locating the number in question, -1. I'm going to put an open circle on -1 to know that that's my starting point. I'll look back and I notice that x is greater than or equal to -1. It means I want to include -1 in my solution set, so I'll darken in the circle. Now I want all the numbers that are bigger than -1, so I know I want all the numbers to the right of -1. I want to include 0, 1, 2. I also want to include 1/2, 1 1/2, -1/2. So rather than trying to list all those numbers, I'm just going to simply shade my line darker to the right. This would indicate x is greater than or equal to -1. The solid circle means the equal to, and everything shaded to the right means greater than. This is a much easier way to show the solution to an inequality. We're going to do it by shading on a number line.
Besides being a school teacher and owner of 3 businesses, I've also worked as a tool and die maker, tool designer, and operations manager of a large tool and die stamping shop. I have here a part that was stamped out of a piece of sheet metal. I've done most of the design work on this part. And this is a hinge die. As you can see right over here, this is a hinge. And this is used like in coal mines or where big conveyor belts are. This comes apart and they put a pin inside, and then they put rivets together and hold the belt together. And the way this die is made, it comes in a flat piece of sheet metal, and the holes are stamped first. Then we notch these parts over here, and then we bend these holes and bend this little tab down, as you can see over here. And then we bend this. And we're going to be talking about bending this radii, and then we go and bend it totally underneath. We come in with a cam and bend it, and then the press just keeps on going on. Then we have a little micro switch which hits it. Then there's a cutoff, and the part falls off and just runs continuously. That's how stamping dies are made. And what we want to determine is the bending radii of various parts. For instance, if you notice this part, this is a transformer, and this was made in the stamping die. You see little folded edges? And you notice there's a bend radius here and over here. And that determines the length of that piece of metal that was bent to make that part. Here's an AVR, automatic voltage regulator. And again, we see this part straight, then there's a little radius over here, another radius over here. And there's formulas to determine the radii, and this is the formulas for bend radii for 90-degree bends. Thickness of material is T, R stands for radius of the bend, X the length of the material after the bend, and M material required for bend. Now this is the M, that's the material that's required. T is the thickness, and this is the radius. And what that means, if you have a material that's this length, let's say that's 4 inches. And you want to put a bend in here, that material was stretched. This material has to be longer. You have to add material onto this, and these formulas will tell you how much material you have to add onto it when you bend it around for 90 degrees. Let's look at this one. The radius here is 1/16 of an inch. In other words, we're going to have a 1/16 inside radius on that bend. Now that radius is less than 2 times the thickness. Now the thickness is 1/16, so 2t equals 2 times the thickness is 1/16, and that equals 1/8 of an inch. So since radius here is 1/16 of an inch, it's less than 2t. So we use this formula, M equals radius plus 0.33 times the thickness times 1.57. Let's put in the numbers. M equals radius is 1/16, or we'll just put that in parentheses, 0.0625 plus 0.33 times the thickness is again 0.0625, and we got to multiply everything, that entire formula here, by 1.57. Let's go to the calculator now and do the math. We'll first multiply 0.33 times 0.0625, and that equals, and we have to add over here another 0.0625. That's plus 0.0625, and that equals 0.083125, and we have to multiply that entire parenthesis by 1.57 times 1.57, and that equals 0.1305, and we'll round that, so M equals 131, 0.131. So M equals 0.131, 131 thousandths of an inch. And so we're going to have to add now onto this piece of material, it's 4 inches plus 0.131. So now the tool and die maker will know they'll have to leave that material an extra 0.131 thousandths of an inch longer to achieve the bend radius if it's less than 2 times the thickness. When the radius is 2t to 4t, then we use this formula. M equals radius plus 0.4 times the thickness times 1.57. And that's what this is. Radius equals 1/4 of an inch, And 2t to 4t would be 2 times 1/16 is 1/8 to 1/4 of an inch. So that would fall within this category. That would be equal to. And 1/2 of an inch will be greater than 4t. 4t, remember, is 1/4 of an inch. So then you would use this formula. M equals R plus 0.5t times 1.57. So when you see when we use less than, equal to, or greater than, there are practical applications.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.